In this video, we'll look at the standard matrix for a linear transformation. The problem is to find the standard matrix for the transformation from R2 to R2 that first rotates a vector by 30 degrees clockwise, then reflects it in the x-axis. Let's call T1 the first step of the transformation. This is the rotation by 30 degrees clockwise. And let's be careful that that's a rotation by negative 30 degrees. So we could draw a little sketch here. Clockwise rotation is this direction, that's negative rotation. So to get the standard matrix for that part of the transformation, we'd write standard matrix of T1 like that. We need to know the standard matrix for any rotation, and that is cos theta, sine theta in the first column, and minus sine theta, cos theta in the second column. And this is going to be evaluated at an angle of negative 30 degrees. So plugging in the appropriate angle here, we've got cos of negative 30 degrees, sine of negative 30 degrees in the first column, and then negative sine of negative 30 degrees and cos of negative 30 degrees in the second column. So I just want to be a little bit careful about the signs here. Let's remember that the cos function is even, meaning cos of negative x is equal to cos x. And the sine function is odd, meaning sine of negative x is equal to negative sine x. So that will help us out with our signs here. In the first column, we've really got cos of 30 degrees minus sine of 30 degrees. And in the second column, we've now got sine of 30 degrees and cos of 30 degrees. Last thing we could do to make this a little bit more specific is just evaluate these trig functions. So over on the side, if we want, we could draw our special triangle. Let's say this is our 30, 60, 90 triangle with our 30 degree angle right up at the top here. Side lengths would be 1, root 3, and 2. So that tells us that cos of 30 degrees adjacent over hypotenuse is going to be root 3 over 2. Sine of 30 degrees, that's opposite over hypotenuse, is going to be 1/2. In the first column there, that entry is minus 1/2. And then in the second column, we've got 1/2 and root 3 over 2. So that is a standard matrix for the first part of our transformation. Now let's look at the second step in our transformation. Let's call that T2, and that is reflection in the x-axis. To get the standard matrix for T2, we're going to think about the definition of the standard matrix. What goes into the first column is the image of the first standard basis vector, so the image of the vector 1, 0. Now, really, if I'm careful about the notation here, our transformation at this step is called T2, so I think I'll say T2 of 1, 0 goes in the first column, and T2 of 0, 1 goes in the second column. That is the definition of the standard matrix for any transformation. All right, so we could draw a little sketch over on the side here and see what these images look like. If we start with our first standard basis vector, 1, 0, and we apply this transformation of reflecting it in the x-axis, what we're going to get is the original vector. So I could write T2 of 1, 0 is 1, 0. That vector has not changed when T2 was applied to it. Now if we look at our second standard basis vector, the vector 0, 1, and we think about reflecting that in the x-axis, we're going to get this vector here, meaning T2 of 0, 1 is equal to 0, negative 1. Now we have all the information we need to complete our standard matrix. So filling in the columns into the first column, we get the image of the first standard basis vector, which is 1, 0. And into the second column, we get the image of the second standard basis vector, which is 0, negative 1. Now that we've got the standard matrices for each step of the transformation, we'll need to think about how to put these standard matrices together. I've written down the standard matrices for the two parts of the transformation that we had on the previous screen, and now we need to think about how to build the standard matrix for t. Well, the idea is that the standard matrix for t is going to be the product of the standard matrices for each step of the transformation, but we need to be a little bit careful about the order in which we multiply these. The multiplication is actually happening from right to left. So the first step in the transformation, we need to have that standard matrix on the right, and as we do subsequent steps of the transformation, our matrices are multiplying in on the left. So we've got the standard matrix for T1, and then on the left of that, standard matrix for T2. A good way to think about this is to realize that if we were applying this transformation to a vector, we'd want the standard matrix for the first part of the transformation to multiply with our vector b first, and after that, we could apply the standard matrix for the second step of the transformation, etc. So these standard matrices multiply from right to left. To finish off the problem, we'll multiply our matrices, just making sure to write them down in the correct order here. So multiplying through, on the top we've got root 3 over 2 and 1/2, and on the bottom we've got positive 1/2 and minus root 3 over 2, and that gives us the standard matrix for the transformation t.